Hello everyone, I welcome you all to this wonderful session. This is a session whereby we are going to be showcasing or presenting a database project titled MediCoreX, a smart, scalable electronic health record system for multi-branch hospitals. So this is a project whereby it's going to solve a solution of record management. Back then, we used to have a file-based management system whereby within an hospital or a health center, records were written on paper, whereby they were stored in files and actually accessed within the files. And this looked to be extra tiresome, and it could not support some areas whereby in case of emergency, let's say a patient is transferred from one hospital in region A to another hospital in region B, time whereby it's an emergency situation, the patient needs to be worked upon, but before making an informed decision, you had to first cross-check about the records. So it could be ineffective, and actually within that short run, we could lose a life. But thanks be to the technology whereby we are now embracing a digitized system whereby everything can be accessed and retrieved effectively and very fast. So this is, as I noted before, it's a database project, hence we are dealing with a database. Let's say call it a can in a layman's language, whereby we can store all the information. Let's say we can store all the health records within, and they can be accessed and retrieved effectively. So by the names of Joseph Semakula, your presenter today to take you through this wonderful session. So a little about me. I am a student at Mbarara University of Science and Technology, and I'm under the Faculty of Computing and Informatics. Therefore, I'm doing computer science. This course name, it's database systems. The course code is there. I'm in year 1, semester 2. My instructor name is Dr. Kenneth Baguma, and as noted before, I'm here to take you through a database project presentation, and our database project title is MediCoreX, a smart, scalable electronic health record system for multi-branch hospitals. As you hear the name, it's for multi-branch hospitals, meaning it can work across hospitals, whereby if you're in a region A, within a given hospital, and you are maybe at a given time you are in another region, in another hospital, still you can access these records which were recorded in the other previous hospital or health center. So without wastage of time, as I introduced myself by the names of Joseph Semakula, and I'm here to take you through this wonderful and fabulous project and presentation. So generally, we have to first tackle why this project. So generally, before we look at a project, we generally first look at a problem and this problem encountered. So we look at the solution tech-wise. So it came across my mind whereby there should be a system which could manage these records. Just as I've told you, just imagine in an area of emergency whereby I'm having a patient. That patient has been transferred from one hospital to another, and therefore to make informed decision, a health worker, be it a surgeon, be it a doctor, need to first access the previous status of this patient, and the patient needs an emergency operation or needs a work on and needs a hands-on immediately. So just imagine a doctor going into the files and digging deep to know the status, and thereby after knowing everything, there he or she could make that decision, and before you know, the patient is no longer there, the life has gone. But thanks to the technology that we are having this, whereby we are having easy and fast access of records. Before you know, within a second, you've already derived the necessary information, the status is already known, and therefore informed decisions can be really very, very effective and could be made immediately. Therefore, this is very good, and this is really very nice, and it could save many lives. So in this area, the healthcare, which is the area of interest, there are also other possible problems whereby they are addressed by different database systems in this area. We have the patient management system. This deals with the patient, the inpatient, the outpatient, and how they are managed. So we also have the hospital billing system, whereby this deals with the finance. How do you pay? How much do you pay? To make sure that the patient is not actually taken advantage of. So we also have the pharmacy inventory system. This deals with prescription, how are drugs prescribed and which kind of drugs were prescribed. So we also have the laboratory information system, and this deals with the lab tests and the lab results, and everything could be stored therein for easy access. Why EHR? Why this project? Before we know why, I would love to first inform you about what is EHR. So EHR is a digital version of a patient's paper chart designed to store, manage, retrieve health information electronically in real time. It contains a patient's record, medical history, diagnoses, prescription, lab test results, appointment records, and more. So all these records are collected and they are stored within one container, whereby within this container they can easily be retrieved and accessed, other than looking for files and looking for paperworks. So why is this important? Number one, there is a centralized and organized patient records. Just as I've briefed you all about that, we are having only one CAN, we are having only one database whereby we are keeping all our patients' records. So it is centralized and it is organized patient, and it's in that case we organize the patient records whereby we keep all medical data in one place. No need to dig through paper files and that tiresome fragmented systems. Hence enables faster decision making, whereby data is retrieved very fast and in a coordinated way, whereby it coordinates care among doctors, nurses, and specialists, or any other health user group. So we have also fast access, as I've talked about or pinpointed before, and we also, be it that this is a centralized container where all records are accessed, we should guard it safely. Thereby we have security and privacy protocols, which are the rules to follow. In this, we ensure data is accessed by the relevant users, and their data is organized in views whereby each user group can access a given type of data. Not all the data can be accessed by anyone. Therefore, we are ensuring access to only authorized users that can view, edit specific records, and all changes are logged, making the system more accountable than the tiresome paper files. Very first, to take you through the details of our project. This project is a database-driven electronic health record system developed as part of a database management system. I would like to inform you that this is my practical assignment for assessment and marks through my program. Therefore, it is going to be assessed. So it's going to be assessed and examined carefully by my lovely instructor. Hence, the assessment will be inaccountable for my results. So the core object of the MediCoreX is to provide a structured, efficient, and a secure platform for managing patient health data within a healthcare institution. The system is designed to handle vital tasks such as patient registration, visit tracking. A patient can register, a patient can be able, or any other user group can be able to track, be it you're authorized and authentic. You can be able to see and you track health records. This is generally more needed by insurance companies, and whereby they track the records and they know. So when an order is made thereby to facilitate a given condition, a health condition of their client, it's very easy to to approve it, since we have the records and we can backtrack about that. Therefore, they are not deceived that maybe a patient is having this chronological disease, but yet it had never surfaced before. So this is more in accountability, it's more in a lot of decision making related purposes. We also have prescription management, whereby each drug or each medication prescribed to a patient, it's taken record of for accountability. So we also have doctor-patient interaction, whereby inquiries or any information required by the patient or required from the health worker, be it a doctor, a nurse, or a specialist, can be accessed. We can also store lab results and documentations for accountability. The project follows a systematic DBMS development life cycle, starting with the requirement analysis, and therefore we go to the business case development. This deals with the risks, the profits. If I'm to invest into this project, if I'm to deploy this project, what are the profits? What are the risks am I supposed to take? Who are the people to benefit? All this is going to be discussed. It's followed by the logical and the physical database design. I'm going to take you through the logical and the physical database design of our project, how it's implemented by MySQL, and finally executing sample queries to validate functionality. Now, the design processes includes a comprehensive ERD model. We have normalized table structures, whereby this enables to reduce on data redundancy. Data repetition, whereby in a file you may find out that in the lab center they asked you about the name, they asked you about the gender, they asked you about some relevant details about the patient. Then before you know, in the pharmacy as we are prescribing, the same data is also again requested. So it's a bit tiresome to repeat yourself. So we are reducing on these problems, hence providing a solution of normalized data table structures and relevant relational mappings to reflect the real-world healthcare and workflows. So, without wastage of time, I would like to take you through the business case, whereby we'll first look at the task stroke processes supported by our system, patient registration and data entry. As already explained, that the patient can register, we can insert into the data into our system. We can it can avail appointment scheduling, whereby you need to say a given specialist, you schedule a date and time. When you automate, this saves time, whereby you go into queues and you stand the whole day, and at the end of the day you're not worked upon. We also have documentation of medical history. As I've talked about, we can track records, diagnosis, prescription and lab results, as I explained before. We can also do reporting and billing, be it an insurance company, whereby we are doing accountability, we are authenticating a given order placed by a healthcare. Is it true? Is it true that our patient is suffering from this disease? So we cross-check our back results and we try to see, has this situation ever happened before? If yes, then information could be authentic. So in so doing, we are targeting which user group served. In so, number one user group, you have the physicians. These could be doctors, this could be pharmacists, these could be nurses. We have administrative staff to manage how are the systems, how are the services within a healthcare being conducted, and for accountability and report procession. It could also be of an importance to a patient. We talked about appointment scheduling. Don't you think that this could be an advantage of a patient to save time than like I talked about before, whereby you come into a queue, you line up to see a given specialist, and at the end of the day you're not worked upon. And so if you make an appointment, you agree on the time and the date, it could save your time and you do other things. So it's also important to the patient. So let's go into the analysis of benefits. These are categorized into tangible benefits, whereby we are looking at quicker patient data retrieval. I gave an example of an emergency whereby a patient is transferred from one hospital to another. So, and again, we have to first get track of their status and into records, whereby you can deal with we look at their pre status and we look at how they have been proceeding health wise. Then we make, or the health worker makes an informed decision according to the history or the status of the patient. So this could be a little delaying, whereby you have to go through into the files. We look at we read through to make to know the status and the details of a patient before we make the informed decision, and this could take time. So if the patient needs an emergency or an immediate hands-on or an emergency operation, so and we take all this time, you see how we can lose a life of a patient. So in so doing, we have this solution whereby we have quicker patient data retrieval. Within seconds, we can be easy to access the data, and within a minute we make informed decision. Then the patient is worked upon within time, and we save a life. We have reduced paperwork. Just imagine you writing every hospital having its own files where it stores its record. This is quite tiresome. We have fewer duplicate tests, as I've told you, whereby you go and a given department, maybe the labs, they ask you for your details, your names, your what, your gender. Then after there, you go to a pharmacy, they too request for your details. So it could be really tiresome. These duplicates, they make life hard for sure. So we also have easier bidding and reporting. I talked of insurance companies whereby they use this data, they can access this data to verify the orders or the reports being retrieved from a health center. So the intangible benefits, we also have enhanced patient satisfaction, whereby the patient can really know, so through the their status, through their background, through everything. By the way, this is very, very important. Just imagine you could not even be a patient. You could be someone who is looking for a spouse, but you don't know each other's status, you don't know each other's records. Through this system, you can be able to access those details whereby you could know my partner's status. You know each other, hence you make informed decision not to end up with a partner who is going to actually cause your kids to be liable about some chronological disease, hence losing your loved ones like children. So we have enhanced patient satisfaction. Through this, you can make informed decision and you're satisfied and you save other problems in the future or in the long run. We have better coordination of care. We have compliance of legal and insurance requirements, as I have pointed earlier. Hence, we now go into analysis of costs. What does it take? How does it take for me to have this system in place? We have divided into tangible costs, whereby we are having what do you need? You need a server and a hardware setup. You need a database development and software licensing according to your region or country. IT support and training. Your workers have to be trained how to use this system. We also have another category of costs which are intangible, whereby you have staff training and resistance to adoption, whereby many of the health workers may think that the system has come to replace their jobs. No, the system cannot reason. The system cannot think. It also needs assistance by the staff. So we have to just adopt by the new way. So we also have time required to digitize all records, whereby entering all the files into this new electronic record health system. We have potential temporary slowdowns, whereby into the system it could slow, but this could be addressed. Actually, this could be readdressed in the setup and maintenance. This takes us to the estimated budget. How much do I need? This is really important. Before you go for in something, it's really very bad to start something on the way and you fail to complete it because of you didn't know how it really cost. So this is a table whereby it shows initial setup according to Uganda. It's an estimated budget according to Ugandan shillings, whereby you have initial setup, we have infrastructure, we have support and maintenance, we have training and rollout, we have optional mobile app and websites. So risks assessment, we have technical risks, data breach or unauthorized access. we have system crash and downtime. We have integration with lab stock radiology software, whereby all these risks can be taken care of in maintenance. We also have organizational risks, whereby user resistance, have miscommunication during rollout, dependence on technical support. Limitation of the system. It's not a substitute for all human decision making. That's as I've pointed out, whereby we have not made a system whereby to replace humans. This is a system whereby it requires actually humans to facilitate it. So we are not going to lose jobs, we are not going to, but we have to just adopt to the new system. So it requires constant updates, medical codes and standards. This goes into maintenance, as most of the risks we have looked at previously, there are risks which are concerning maintenance. May not cover specialized hospital departments like ICU and surgery. You must take care of that. Downtime can disrupt entire operations. So we have also some other user issues, whereby the need for training in the user system. We have users may lack technical skills. This can be addressed through training. Workflow changes may face resistance, and this through workshops and speaking to our staff, we can incorporate this system into our workflows. We have early versus late adopters. As I told you, we have the other file-based system. Now we are shifting to the new electronic system. This could be somehow challenging, but through interaction, through workshops, through maintenance, through setting up everything as it's required with specialized IT personnel, we can overcome all these issues and risks. So here we go to the logical design. Our logical design, I listed a few entities, whereby we have these are like tables or objects. We have patient, we have physician, we have appointment, we have diagnosis, we have treatment, we have prescription, lab test, medical records, there are quite many, and admin staff. This takes us into the attributes and the entities and their attributes. Under the patient, we have patient ID with as the primary key, the first name. It will also ask for your last name, date of birth, gender, phone, email address, such that it's very easy to address and to contact you. We have the physician. They also need a physician ID as their primary key, just for data integrity. We need their name, specialty, the phone and the email for in case to reach out to them. You can also have the appointment, whereby the appointment ID is the primary key. We have patient ID as a foreign key to refer to the patient. Physician ID as a foreign key to refer to the physician. Date, time, and the status where you are picking or you are putting or you are placing your appointment. We have diagnosis. We have diagnosis ID as a primary key. We have appointment as a foreign key, whereby through the diagnosis you can be able to place your appointment. So diagnosis can also be referring to the appointment. Description and the date. There are very many. I won't have time to pass through them, but as indicated in the table, that's how they exist. We also have entity relationship, whereby a patient has appointments, a physician attends to appointments. Only one patient can actually attend to many appointments. Only one physician can attend to many appointments. It's only one appointment that may result into a diagnosis. So a diagnosis can have very many multiple treatments. Therefore, this is, we shall see in the multiplexes how this technical details mean. We have diagnosis, whereby a diagnosis can have a multiple prescription. A patient can undergo multiple lab tests, and a patient can have multiple medical records. Therefore, allow me to take you through the multiplexes, which we have. We have a patient. One patient can only have. We have only one patient. Therefore, a patient can have very many appointments. It's zero to many. Each patient can have 0 or more appointments. A patient can have an appointment, or a patient can never have an appointment. Therefore, it is 0 or many appointments. Each appointment is associated with only one patient. These are very, very, very necessary for reduction of repeated information, redundancy, and data integrity, as I pointed before. So a physician, we have only one physician. A physician can have multiple appointments, and each appointment is with one physician. You can never have an appointment with very many physicians. Like each appointment is directly addressed by one physician, and a physician can have many appointments. This is all for our data integrity, security, reduction of data redundancy, as in files whereby we always repeat ourselves. Here we are trying to reduce that. Very minimal pieces, but those are the samples I managed to add into our presentation. Here, this takes us into the entity relationship and attributes, whereby we are looking at our ERD diagram. ERD diagram, it shows the workflow, who is related to whom. We have our patient being related to a physician in a given way, and our physician, they also relate to a diagnosis. We related to a prescription, whereby within one diagnosis, a diagnosis can lead to a prescription. A patient can see a physician. Within an appointment, we can make prescription, and within an appointment, we can access a given medical record, and within an appointment, we can access lab tests, and within a lab test can be under a medical record, and a medical record can also have prescription. Therefore, a medical record can have a lab test, and a medical record can have a prescription. An appointment can result into a lab test, an appointment can result into a prescription. A patient can see a physician, and a physician can work on a patient. At the same time, that physician can diagnose a patient using a given prescription. Hope this one is clear. Normalization, this is really very important as one of our solutions to outcompete the file-based system, whereby in a file-based system, we used to write everything in files and jot it down, whereby we're having repetition. If you're writing about someone, as I talked about earlier, whereby you go to a department of maybe you've gone for a lab test, they need your name and your details. The same, it will be requested from you, from let's say from prescription, or from let's say the pharmacy. So there is a lot of data repetition, and this actually, it's really alarming, it's tiresome. So through this our system, we have a solution to this, whereby we normalize. It means we are getting rid of all repetitions. So through this, our MediCoreX EHR system database is normalized up to a third normal form to eliminate redundancy, ensure integrity, and this includes separating patients, medication, appointments, and other related entities into a well-structured, non-redundant tables as seen below. So here, we are having a patient, we're having our records being divided into patient, doctor appointment, medications and medication, whereby we all access them in a centralized way without repetition. So this saves and this actually reduces on the tiresomeness faced by you telling every department about your details. So you can see here a patient ID, it can be here a patient, but at the same time in medication we request for a patient. So this one is gotten rid of. Since we are having one system, everything can be contained therein. So hence we are eliminating data redundancy, and we are ensuring integrity. We also have user interface, and user interface deals with what does the graphical user interface, what do you see actually our system, because we have a lot in the background, in the technical bit of it, but what would our views look like? So this is the time for me to take you through. So here we have a patient registration form with fields of the first name, last name, date of birth, gender, and the contact info. This is the registration bit of it. So this is a view to a patient. This information can be accessed by the patient. We have appointment scheduling, whereby patient, we select a patient, can select a physician and the date, time and status. In case we are tracking, we can select a patient, then we retrieve all this information: when, at what time or which date did you see or did you have an appointment with a physician. And also a patient can actually select a physician, schedule a date and time and the status to see that given physician. So you're seeing this system, it's really working nice, and it solves a lot of problems we encounter within the health sector. Another user interface, we have the medical record entry, whereby we select a patient, enter the diagnosis, treatment and prescription. Through this, in case for let's say you're placing, as I was talking about, placing an insurance order, whereby you're requesting for funds to facilitate a given patient with a given condition, whereby here we could be able to retrieve all the information required before we make that informed decision. We select a patient, we could be able to view the diagnosis made about that patient, not only that current time but also the previous times. Therefore, we can also view the treatments received by that patient, not only this time but also the previous times and the prescription. Therefore, we can actually tell the progress of a patient. Is this treatment working? Is the prescription really working? Who is in charge? In case of any errors, we can easily trace and know who made the errors. So we have lab test entry, whereby instead of walking downstairs, whereby the lab is on the ground floor or on the upper floor, and whereby the pharmacy is also in the east, and whereby within the hospital you have to walk a lot of distance, whereby to access all this. Through this, you can just sit down on your device and you access the lab tests, and actually you can actually also press appointments there for a lab test, and actually they can send you the result instead of you waiting for them. They can actually diagnose the results, they schedule them, then they send them to you, and this is quite effective and within no time. So we also have our user interface, whereby it handles errors. In case of an error, how does our system respond? Does it display a message? You could be working with the system but you don't know you're making an error in your name. You could be working with the system but you don't know you've made an error in a date of birth. So our system can handle all these errors and display messages to tell you where you went wrong, and actually advises you accordingly through a message displayed. So we also have a sample of the graphical user interface. I managed to get for you the user selection, whereby when you log into our system, how do you select which kind of user? This actually is very important, whereby a patient cannot act as a doctor cannot act as a patient. So you're seeing how our system is really working nicely. So this is the interface or the dashboard that welcomes you to our system, whereby here you select, then you sign up, and therefore you log in, and this ensures security about our data and who is accessing our data. So we also have the sign up page, whereby if you sign up, it takes you to this frame whereby you could enter your details, then you save them. Thereby it keeps track of who is entering, who is accessing which kind of data. So through this, actually we have the sample graphical user interface also continued, whereby I talked of the error management. You can see here, in case the system has failed, or in case of system failure, it displays for you a message. Then you could be able to know, is it network issue? Is it I need to try again? Have I made an error in my credentials? So all this the system could handle. So it also I also managed to get for you a doctor's dashboard, how it looks like, though the system was it is still under development. So by the time I made this presentation, the system was under development. So most of the things they look quite unfinished, but at least we can be able to know what the system does and what it's capable of. So more of the graphical user interface continued. You can see, in case the system is loading, it can you give it some time. It tells you, give me some time. I first finish what? I finish loading a given information. So you give it some time, it loads for you. Sorry about that. So you are also having a doctor's dashboard, whereby you are able to add This is the interface whereby you, a doctor or a health personnel can be able to what, to insert the data into the system, whereby if you add a patient and the details, all patients can actually be retrieved down here, and the doctor can easily be able to know which patients am I working on today, which patients am I having today. So all this, they are actually supported by our what, by our system. So I take you through another schema. Whereby here we look at the SQL database and table creation using MySQL in the console. How did we develop this? How did we use MySQL to develop this? I managed to get for you some sample whereby we created our database. This is how we created it. We effected some sample tables, we created them, they executed successfully, and actually I made this is a sample of patients table, the physician table, and very many other tables. So actually this takes us into the physical design of our project. So this is a sample of how we inserted some data into our database, whereby in case you have encountered a patient, given patient X initial consultation, whereby this is her first time or his first time to consult, the follow-up, the routine checkup, all these are maintained by our what, by our database project, or by our system. So here we're inserting some sample appointments. You tell us a reason. Is it your initial time to meet our physician or a doctor? So that is initial consultation. Then the follow-up, how are the situation? Are you recovering? How far with your health? How far with the prescription? Are you taking the drugs as prescribed? So there is all that follow-up. There is also scheduling, diagnosis. Do you need a cardiac check? And very many other things which I won't go into details at this time. So here, after making all that, we have to test our data, whereby this ensures that the table names are consistent, foreign keys references point to the existing tables of columns, whereby this ensures data integrity, and as I told you, it reduces the redundancy of data repetition. So you are trying to insert nows into the required fields, so you cannot insert emptiness, or like you continue with within our system in case certain fields are not required, fields are not what, are not having the existing data or are not filled. So this is a sample of we testing our data in case the system, the data in the system is working actually as expected. Here we try to retrieve some information within the tables or our entities, and it really worked successfully. So from our appointments, the data we input, you can see it is still here. From our diagnosis, the data within our entity tables, it's also showing here with description. So everything is working well. Hence, it's a working system. So we also have our system view, whereby we tested the view of appointment. Can our system clearly retrieve the data within appointments with the physician and using the patient name? And it really did so. So the system is working wonderfully. So here we have reached at the start of our conclusion of the presentation, whereby it's high time to look at the future improvements. How best can we improve our system? This system is not static, it is a scalable system which can allow improvements in the future run, meaning you can start small, but later you make it into a bigger progress. You make it into a larger system which can actually solve a lot of problems which can solve right now. So you add on it more functionalities. So it is scalable, as I've talked about. It can be increased, whereby if it's now taking care of the records, in future it could actually take up in note or in consideration of other improvements as required by the stakeholders. Our system has optimization of ideas, hope to optimize more and more according to the feedback of the users. Additional features like AI integration are also yet to be added, whereby we integrate the AI, and whereby now we use more of AI to make informed decisions and actually determine more about our future considerations, hence not neglecting any critical bit of the data or any critical bit of a record not considered. So you've been good listeners, good viewers, and here comes to the end of our presentation with the closing remarks. In conclusion, the MediCoreX EHR system demonstrates a robust, well-normalized database designed tailored to streamline health data management by applying best practices in normalization. We have no data repetition here, hence it's very easy to work with. It won't tire you, and ensuring seamless relationships among patients, doctors, appointments, and medication. All the user groups are actually working hand in hand and very happy, and with less energy but effective actually role and work done. So allow me to take you through. Our system is actually promoting data integrity, scalability, and easy of use. We are confident that this solution can support efficient clinical operations and lay groundwork for future innovation in electronic health records. Thank you all. Thanks for listening. Thanks for watching. I remain Joseph Semakula. Stay blessed. Thank you.